Boom, boom. Good morning, good morning, good morning. We're going to be looking at drawing bearings for right triangle trig problems. And this is just a practice. We are going to sketch. Hopefully this will help you out as we go further into some problem solving. So drawing bearings are nice and easy. It's all about directions. And when we do that, we need to think about our compass rose. And we think about that in terms of north, south, east, and west. All right, so there's our compass rose. And what it'll say is we need to draw a bearing of, for example, 0 degrees. Now, when we do that, we have to understand that north is where we start with 0 degrees. East then becomes our 90-degree mark. South becomes a 180-degree bearing. And west becomes a 270-degree bearing. So unlike most of our problems in which we start on the x-axis as 0 degrees, when we talk about bearings, 0 degrees will start on north, and then we will work clockwise from there. So if we're going to draw or sketch a 60-degree bearing, it's nice and easy. We actually just start at the y-axis there, or north, and we just work our way down approximately 60 degrees. I'm going to draw that angle between 0 and 90 degrees, and it is just a sketch which tells us that that bearing is directionally at a 60-degree bearing or out in that direction. That also should tell you that based off of what we know, we also have the direction that, or the angle that is in 30 degrees in respect to east or the x-axis, and that will help us out with calculations later on. So let's go to 135-degree bearing. So I start in this case going back to the original setup, which is, hey, I've got north, south, east, and west. North being 0 degrees, east being 90 degrees, south being 180 degrees, and west being a 270-degree bearing. Okay, now when I do 135 degrees, well, the really important part is that reference of 90 degrees. I know if I go past 90 degrees in order to get to 135 degrees. So I have to go past that mark, and then I can just sketch it in there. Okay, it doesn't have to be perfect. It's just an idea that, hey, this angle is past 90 degrees, but it is less than 180 degrees. And I would say, hey, that's a 135-degree angle. Now, the one thing that I want to do is I love to reference back to that x-axis. So if I'm going to reference back to that x-axis, I'm going to say, well, how many degrees is it from here to here? Well, I say maybe 135 minus 90. Well, that tells me 135 minus 90, that's a 45-degree angle. So it is a 45-degree angle with respect to east or the x-axis, but the bearing from north is directionally that 135-degree angle, which tells us we're probably going around southeast. Okay, let's go ahead and do 295 degrees. Okay, last one that we're going to do for practice. So I'm going to come over here. I'm going to go right back to the same idea that we focused in, that we've got north, south, east, and west. And then I'm going to put 0 degrees, 90 degrees, 180 degrees, and of course 270 degrees. Now you may be able to see where a 295-degree bearing lands. Okay, well, let's just sketch it out. So 295-degree bearings. I know I got to go past 90 degrees, got to go past that. I need to go past 180 degrees, and I need to go past 270 degrees. So I'm somewhere in this quadrant right there. Okay, and now when I draw that, I'm just going to sketch it. It doesn't have to be perfect. And I'm going to start at the origin. I'm going to say, okay, well, we are going in this direction. Looks somewhere like northwestish somewhere. Now, as I've done in the other angle, in the other problems, I'm going to reference it back to the x-axis. I'm going to say, well, okay, well, I can reference that angle back to the x-axis. And I can say, well, we went 295-degree bearing, which we have a reference of 270 degrees. Okay, well, that leaves us with 25 degrees as a reference back to the x-axis. Okay, but with that being said, the bearing was a total of 295 degrees. And we do have a reference back to west, or the x-axis, of 25 degrees right there. Hopefully that helps you all draw bearings, and we're going to be applying them to word problems.